This is Sung. I'm the Principal and Director of Sky Academy, and I want to welcome you to this 2-unit course where I'll be going through a whole bunch of video tutorials that basically cover everything that you need to know in the 2-unit course. I want to start off by going through some basic arithmetic. In fact, the first couple of units in the 2-unit course are designed to get your foundations set. Alright, so the first topic will be basic arithmetic, the second topic will be basic algebra. And in order to really excel in the 2-unit course, you need to have those things down pat. Okay, so let me start off with some basic arithmetic, which really isn't as basic as it might seem. But before we launch into all of that, I want to actually introduce you to the idea of number systems. And the real number system is important because it gives us all the different subfields or all the different fields that exist within the real number system of how numbers operate. Okay, so for example, I want to go through the different types of fields or the different types of number systems that we deal with. Alright, so the first type of number system is what we call the counting numbers, or the cardinal numbers, or the natural numbers, or the whole numbers. They're different words for the same thing. And what that is basic counting numbers, 1, 2, 3, 4, whole numbers that we can just count. Alright, it's the oldest number system. It's the number system that basically, you know, our cave dwelling ancestors kind of dealt with, right? And it's the most primitive number system, but it's often very much the most useful, and it also has very fascinating properties as well. Okay, so the natural numbers. Now there is a bit of an argument as to whether 0 is to be included in our natural numbers or not. Okay, and you know, I'm sure you can find people that say yeah, 0 should be included in our counting numbers, 0 shouldn't, and then there's people that would argue that 0 shouldn't be included in our natural numbers. All right, and I guess it all goes back to throughout history where that 0 really was accepted as a number in and of itself. The whole idea of accepting a non-number or a number that represents non-existence as a number is really only a modern idea. So there's often debate about whether 0 is a natural number or not, although it definitely is an integer. Okay, but whether it's a natural number or not is up for debate. We're going to include 0 in our natural numbers. Okay, so that's what natural numbers are, and it's represented by the number capital N. The next type of number or number system is integers. Now, the only difference between counting numbers and integers is that the integers also are counting numbers in the negative case as well as the positive case. So they're oftentimes, you see them, you probably learnt them in junior maths as directed numbers, and they're numbers that are either positive or negative or 0, which is neither positive nor negative. Okay, but 0 is definitely an integer. And you can probably see it kind of expands out like the rings in an onion in terms of different layers. Okay, the next type of number we're going to deal with is what we call rational numbers. Now, in the word rational, you will see the word ratio. And what a rational number is, given it contains the word ratio in it, is a rational number is a number that can be expressed as a ratio or a comparison of one number to another number. So an example of that is the number half. Okay, it includes fractions, decimals, and percentages. So the number half can be expressed as 1 on 2. It's the ratio of 1 to 2 expressed as another number. Okay, so it's one counting number, the ratio of one counting number or one natural number to another natural number. All right, 0.067 would be 67 as one counting number compared to another number which is 1,000. Okay, so 5 on 97, 0.3 repeater is also a rational number because it's as a fraction, 0.3 repeater is 1/3, and if it can be expressed as a fraction with a a numerator and a denominator as whole numbers, then it's definitely a rational number, okay? So you see the word ratio in there. Rational numbers are actually older in origin than integers, and rational numbers go all the way back to the Greeks who dealt with numbers that were partial in nature. Okay, partial meaning fractional in nature. So whereas integers, positive and negative numbers, is actually quite a modern idea. Now, usually what you'll find is that each of these layers in this onion go from historically the oldest type of number system, or the most primitive type of number system, to the most modern or the most recently developed number system. But this is an exception, okay? And the reason why is because what we want to do in these onion rings is to show that the natural numbers are a subset of the integers, and that the integers are a subset of the rational numbers. What we also want to show is that the rational numbers are a subset of the real numbers, right? Where the other subset, or the complementary subset of the rational numbers, is the irrational numbers. Irrational numbers meaning numbers that cannot be expressed as a whole number ratio of one number to another number. Okay? And examples of that include the number pi, which is what we call a transcendental irrational number, because it starts with the number 3 point, and then it goes 1, 4, and it just keeps going forever and ever and ever and ever. You cannot express it as one whole number over another whole number, okay? Because the number just keeps going and going and going. Another example of an irrational number is the square root of 37. So any sort of square root number that isn't a perfect square, or any sort of root that is not a perfect square, is clearly an irrational number. And there will be a proof. We'll go through a proof where we'll prove that the square root of 2 is an irrational number and not a rational number. But that's a little bit later. Another example of an irrational number is 3 plus the square root of 5. Yes, it has a rational component 3 and an irrational component the square root of 5. But what it is in and of itself, 3 plus the square root of number is a new number, all right, that in and of itself has irrational properties. Now, what's useful about each of these number systems is that you can operate within them. So in other words, using the 4 operation signs, plus, minus, times, or divide. But each of these number systems will operate in unique ways. So the way that you add fractions, for example, is not the same way that you add counting numbers, necessarily. All right? So each of them operate within their own conventions and their own rules, and that's why this basic arithmetic unit is so important, is because we've got to learn how to operate, plus, minus, times, or divide, within the natural number system, within the integers, within the rationals, within the irrationals, and within the whole real number system. Okay? So in this basic arithmetic unit, we will learn to do all of that. Okay, so it will be quite an intense unit, but we need to go through it to really get a good, solid understanding of how to work within the real number system for the benefit of doing really well in the 2-unit course. Okay, so I'll leave it there for this episode, but I look forward to seeing you in future episodes where we will really get stuck into it. Thank you very much for watching.